Okay, so string manipulation with strings are very frequently applied in algorithms, quite an important topic. And today's presentation, we will try to keep it shorter to the theory because there are really a lot of functions to use in strings. So we'll try to keep it short and we'll try to concentrate more on the problems and algorithm side of it. So let's begin. So string basics, now strings like apple, boy, cat, A, B, C, D, E, F, anything of these, a sequence of characters, any sequence of characters is essentially a string. So you could consider string as an array of characters, essentially. You might have learned array in the previous algorithm series. So extending that to strings is nothing but an array sequence of characters. Strings could be empty as well. And there are functions which we will look at later to determine if a string or how to check if a string is empty or not empty. Strings are one very important characteristic of a string, which is also asked during quite a few interviews as well, is that strings are immutable. Now what that is, we will see in the next slide. But just to mention that when we say strings are immutable, we mean that one string object is created, it cannot be changed. And whenever you concatenate different strings together, as we will see throughout our algorithms, it creates a new string every time. You can access strings using index. You can access the different characters in string. Again, there are functions inbuilt into the language which allow you to do that. You don't have to like write any specific functions of your own there. Okay, so to look further into immutability, so as I mentioned earlier, immutable means once created, the object cannot be changed. Every string has a unique address in the memory, and any operation on string, concatenation, substring, etc., would create like a new object. This is kind of a visual representation. So let's say we have two different strings, hello and Python. The first string points to hello, and we want to create a string using the first string and another string called Python. So we form hello Python. Now, when we form that string, that gets created in a separate space in the memory, and a separate block gets allotted to that. So those are two different strings now. So string 1 is pointing to hello, and string 2 is actually pointing to hello Python, although that has been formed by a concatenation or by joining of two different strings. So this is quite an important concept because we would be very frequently trying to use like joining of strings or other operations on strings in different kinds of string algorithms and different kinds of problems that we see later on. So string manipulation, when we talk about string manipulation, we are essentially referring to the process of creating, analyzing, parsing the data in the string. As I mentioned earlier, we already have like a lot of inbuilt functions in different languages to support the string manipulation algorithms. We have like a set of functions in Java. We have a different set in Python. All of them are quite similar, although the syntax would quite differ because of the languages. They are quite useful in programming algorithms. You would come across a combination of algorithms using strings in different data structures. So we will try to keep it limited to some very basic algorithms today. There are quite a number of complex algorithms used. However, those are beyond the scope of today's discussion. We will learn the basic ones. We'll try to solve some basic problems around those. So string functions are essentially, there are like many different functions that you can apply on strings, like accessing a single character or a group of characters, or accessing characters based on the index of that character in the string, length of the string, concatenation, as we saw earlier, uppercase, lowercase, determining if the string has like digits or letters or a combination of both, or special characters. Sometimes there are also situations where you are given two strings and you have to like find whether the first string exists in the second string or not. So there are functions like begins with and ends with that help you search for certain easy patterns within the string. Now I have actually taken very simple functions from Python, simple string manipulation functions from Python, and I have put them here. At the end of the presentation, I have some resources pointed out where you can go and explore more functions, more string functions that are used in Python. Or depending on the language that you use, you would essentially come across a vast number of string functions. So this one, the first function is just printing out whatever string you are passing to it. It's called print. So it's just printing the word, which is hello world. And the second one, you see it's printing out letter, which is trying to get the character at position 1. Now, since it is an array of characters, of course, it's 0 indexed. So the second character, so the at position 1, if the character is E, so that is what it is printing out. The next one is length. Length, len is the entire length of the string, 11 in this case. Hello plus world is similar to concatenation. So when you want to concatenate two or more strings, you could use this function. Functions like count, find, and index. Essentially, find is finding the index of H here, which is position 0. A word dot index of world. So essentially looking at where the string world is starting from. Now this is again an entire string. So it's just looking up the position from where it is starting, including the space in the string. Word dot count L is 3 because L is repeated 3 times in this particular string. So all of these inbuilt functions essentially make it quite easy and accessible to do further operations on string. There will be quite complex algorithms, but all of those might be using a lot of these inbuilt string functions to figure out in sequence. Next one is called repeat. So essentially what it is doing is, so you have a word called hello. Repeat is word times 5, which means it is concatenating hello 5 times and then printing out that particular word again. This word again will be a different string. It's a new string because of string immutability. So that's the output for this function, repeating a string. Next is starts with, ends with. It's pretty straightforward. Hello world is if it's starting with A and it returns false, that no, it's not starting. So that the return type here is Boolean. Word dot end with D, yes, that is ending with D. And word dot starts with H, it is starting with H, so it returns true. So, so yeah, those are some of the examples of very basic string functions. You can find more of them. You will be using more of them when you write down specific algorithms. We will look at two very simple and common string algorithms, string related questions. The first one is a palindrome. We will try to look at how to determine if a string is a palindrome or not. Now, what is a palindrome? So palindrome is any string, anything, or any number which reads the same if you start from the first index or from the last index. So looking at an example here, 1, 2, 3, 2, 1. So when you read it from the front, it is 1, 2, 3, 2, 1. If you read it from the back, it is 1, 2, 3, 2, 1. Similarly, race car. If you read it from the front, it is RACECAR. And if you read it from the back, it is again the same. So essentially, if you look at a very specific structure here, you notice that, okay, this is any kind of string which actually is a mirror image of itself when you try to reverse the string. So essentially the string and its reverse are both equal. So how do we determine if this is a palindrome or not? Before we go on to the solution, does anyone like have any thoughts around this or anything, or wants to ask something? Okay, so let's proceed then. So how do we determine if it's a palindrome or not? A very simple method would be this. So this is essentially reversing, taking the reverse of the string. And that's the most straightforward approach. So you have a string, you reverse the string, that is the function which is doing the reverse. Def is palindrome, S is equals to a reverse of S. So essentially, if that is true, it returns a true. If that is not the same, then it returns a false. And this is the straightforward approach of doing that. You could, there are also other approaches wherein you could just go character by character until the midpoint and then try to compare them. So I go like from 0 to 3, and then I go from the last character to until the midpoint, and I try to see if they are equal or not. You could also try to use a different data structure, for example, a stack, to do that as well. The result would essentially be the same, but there are different ways of like approaching this algorithm, but this one is the simplest one of them. So this is a palindrome, how to check if a string is a palindrome. The second one, a string anagram. Now, anagrams are essentially words which have the same number of characters and same number of letters in that. So, for example, heart and earth, both of them have one E, one A, one R, one T, and one H. So those two are anagrams. Python and Typhon. So again, they have like the same number of characters here. Let's say Python had an extra O, then they wouldn't be anagrams anymore. So it's important that the frequency of the characters in both these strings or in a multiple set of strings are the same for them to be anagrams. We will look at a simple example where we determine if one string is an anagram of other or not. And later in the problems that we have for you today, there is an extension to this problem, where you can use the same logic, but it is an extension of the problem applying to multiple strings. So this is all about determining whether a string is an anagram. To keep it simple, we'll assume that both the strings are of equal length here in this question, and they are only made of symbols from the set of the alphabets, the 26 lowercase alphabetic characters. That is the assumption. So how do we check if the string is an anagram or not? So we could sort the strings, both the strings. So if on sorting both the strings, we see that the characters are the same, then we print that they are anagrams. Otherwise, they aren't anagrams. So there's another example here, listen and silent. These two are anagrams. On the other hand, if I had any character, like let's say I have 2I or 2L in listen, then that wouldn't be an anagram to silent. So sorting is quite straightforward where, okay, you can just take in the string and apply the inbuilt function to sort it. However, there are other methods also to do this, which we will hopefully apply when we do the problem that we have for you today. We can solve it in a simpler way as well. The thing is, in this, when we are sorting a string and when we are comparing this way, the time complexity of sorting itself would be order of n log n here. And there is a method where we can actually compare if the strings are anagrams or not in an order of n, which I will leave to you to solve during the problem solving session. So it would typically probably use additional space because you might have to store the characters somewhere, but you can definitely do it also without sorting the strings at one go. So that is the algorithm what you would use to do to compare the strings without sorting. So we know that the two strings should have the same number of characters. So essentially it's about looping through the characters in the string, counting the number of characters, and then storing the count of the characters somewhere for one string. And then for the other string, we again loop through the characters and just keep on comparing the count. So even if one of the count is unequal, let's say, we can just break from the loop and return a false. So doing that way, you don't have to really use any sorting function. So you avoid n log n complexity, but since you are doing a linear scan, it would be an order of n there. The additional space is all right. It would be like probably as much as the maximum number of characters used in a group of strings. So yeah, probably we can just code it out when we are doing the next problem around this in the other session. So yeah, that's about the anagrams. Now, there are a number of advanced string algorithms. There is a Manisher's algorithm, the Rabin-Karp algorithm for pattern matching, the KMP, Nath-Morris-Pratt algorithm, again for kind of pattern matching, an Aho-Kurasek algorithm, which is used for, again, a string searching algorithm used in finite state machines for regular expression matching. So all of these are, again, based on what we have seen so far, but the applications of these are quite complex, and there are set of defined algorithms. They have already been researched and defined and used. So if you would want to know more, you could refer to the different links and different resources available. But yeah, these are out of the, like, explaining them during a session is not quite possible. So we have kept it outside the scope of this one. Um, so those are some of the advanced algorithms. And these are some of the resources, some good resources to learn about string manipulation, to solve problems on string manipulation, or just to, refresh your fundamentals on string manipulation. So Medium has quite a few good resources on that, and so also Hackadoot. So yeah, I think we will be sharing the slides with you so you can just go through the resources whenever you want. So yeah, I think that is all for the theoretical part of string manipulation. So we have 4 problems today for our coding session actually. So I think we do have enough time to go through them. They are all at an easier level. So yeah, that's about it. I think, Helen, back to you to take over and then, yeah, put us in groups, I suppose.
Thank you very much, Vipsa. This is the end of our theoretical part, and now we are getting to the practical part.